Hello and welcome back. This time we are diving into the response of the model. Let's take a look at the four major sections of our output here. We can see here we have a candidate section, usage metadata, model version, and the response ID. Let's start from the bottom. The response ID is a technical unique identifier for this response. You don't really need this one, it's mostly there if you have an issue or find a bug that you can communicate it with tech support. The model version is the model that we specify in our request, so this is just a check that we can take a look at. Next, let's open up the usage metadata, where we see 5 total information points. First up is the prompt token count. That specifies how many input tokens we send to the model. And the second is the candidate's token count, which is the number of output tokens the request created. These two are very important to keep in mind as they are used to calculate the cost. And in this case, using the Gemini 2.0 Flash model, it's 10 cents per million input tokens and 40 cents for a million output tokens. So this request cost almost nothing. Well, we are on the free tier, so it really didn't cost us anything. Then we see the total token count, which is just the first two added up. And then we see the prompt and candidate token details. They specify which modalities used how many tokens. This can be of interest once we move into multimodal interactions with our LLM. Right now, we see it's only one modality, text, as we input text and get text out, but in the future, this will change. And now, let's open up the candidate section. Here, under content, parts, we find text. And here, I just truncated the response, but this is the full model response. Then, we see the role, which is model. This is important when we end up creating multi-turn conversations with the LLM, and you specify which was given by the user and what was given by the model itself. The finish reason specifies what caused the stop and then the answer from the LLM to be sent to us. You will normally see something like stop, which means it reached a natural endpoint or a stop sequence, or you might see something like max tokens, which means it hit a certain limit of its context length, or you could also run into security or harmful responses here. You can check the blog post to find details on all the other ones. The last one here is the average log probability. Now this is an interesting metric that we get back, which we will also explore more next week. In general, you can think of this as the confidence of the answer by the LLM. The closer it is to 0, the more confident it is. Then you will usually see a value in the range of 0 to like -1, which is fairly confident. If it's below 2, it means the LLM is very unconfident in its answer. Now, let's move on and take a look at what we can do by destructuring our response and printing it in a better understandable way. Here you can see I took the code from last week and just added some additional print statements where I destructure the response. Let's go ahead and change into our directory here and run our output understanding.py. And here you can first see the answer that the LLM sent us. Then we can see it used 36 input tokens, 63 output tokens, the answer confidence is high, and the finish reason is stop. Here I just had a bit of fun translating anything that is greater than -1.5 into high and everything else in low. And then also let us look into the SAS side of things. Again, reusing the same code from last week, I added 2 additional print statements that pull out only the required information here. So let's run this. And here you also can see the text response, the token counts, and then the finish and average log. And you can see that although we sent the same response, the same request to the LLM, we got different results in length, also in the kind of, especially the output tokens. The input stays the same. But this is going to be something that we will be digging into more in next week's episode. I hope you enjoyed this one and see you next time. Bye bye.